Nice to see you all. I was super sad to not make the last one of these, especially, well, I didn't know at the time that I would have to wait a couple of years to come to the next one. So, hello, my name's Dietrich Ayala, and I work at Protocol Labs, and I work on IPFS-related things. And I've met some of you before, maybe all the way back to IPFS Camp, and some of you I work with all the time and only met yesterday or even today. So it's really great to be here. I've been working on IPFS-related things for about 3 years, and maybe a little bit more. And before that, I worked on Mozilla Firefox, the browser, for over a decade. So I come from the Web 2 world and still feel kind of new to Web 3 things. Today, I'm going to talk about a little bit what we do as a team. I work on the browsers and platforms team, and we do things like put IPFS in strange places with some of the people here today. Here's a quick look at what we're going to do in this current quarter. Some of the stuff I'm going to talk about today, but also a bunch of things that we do with other people and other projects, a lot of which means trying to get things like P2P into places that are paradigmatically opposed sometimes, or at the very least, not at all convenient to getting things like IPFS actually working and functioning well. Some of these things actually, like, it was nice to see in Pedro's talk earlier today about how sometimes there's just no right way to do things in IPFS and with P2P, and that makes it really hard when you're trying to convince, say, between 8 and 22 million developers to actually start building on top of this kind of stuff. But these are a number of different problems that we have when trying to get things like IPFS, which is highly dependent on an underlying network architecture and infrastructure that doesn't work the way that HTTP works, into some of these places with some of the projects and partners that we work with all the time. This goes from security and privacy models that are very strict for good reasons in things like web browsers. Sometimes even it's just a culture thing. So hanging out here with people like you, we're all super interested in these technologies. But sometimes when you go and you're talking to browser vendors or security teams at browser vendors, they are basically TLDR, this is a really bad idea. And so those conversations can get awkward, but we persevere, and eventually we will get IPFS and related technologies, or at very least technologies that have the characteristics that we want to see in the applications that we use every day, into things like web browsers. So as we have learned in some of the talks today, this is a highly simplified slide. But this is how a lot of developers think about using the network, think about using HTTP. This looks really different than something like this, which is how I think about what IPFS gives me when I'm building applications. And actually, again, like, super interesting to see in Joao's talk a reference to kind of like the geographic location of data in IPFS networks as you get closer towards the context of a given use case or where people are using IPFS-based applications. And I think that makes that paradigmatic difference between this and this incredibly difficult when you're trying to do things like mobile applications, browser integrations, and all the other places that we want to be able to see these technologies. So I'm going to talk about a couple of the strange places where we've had hard problems getting IPFS into it. So here's like a sadly mostly red, but oddly inspiringly green kind of look at top browsers and where we have IPFS-related technologies, or at least have conversations. And I think when you're building your own application, a lot of times you're like, well, I'm going to use IPFS, or I'm going to use this other technology, or I'm going to use something else. But when it comes to things like browser integrations, we actually have to get the buy-in of people that are building applications for hundreds of millions and sometimes even billions of people. So sometimes something like a publicly positive mention really goes a long way, and itself is even a huge victory in the very long road towards long-term integration and adoption of some of these technologies. Sometimes we have privately positive comments from partners or people that we're talking to at browsers that I won't say names out loud, but may be familiar to you and are interestingly amenable to implementing something like IPFS. The rapid adoption of NFTs has actually changed some attitudes in this regard, which is kind of cool. And sometimes we just have internal champions. So those folks who are like on a bug tracker, on GitHub or Bugzilla or wherever, and are reviewing patches pretty quickly, or at least commenting quickly when we're talking about integration and adoption of some of these technologies. But it's complicated. Between the nexus of IETF, W3C, browser vendor integrations, and all this entailed in just getting regular HTTP or web platform technologies adopted, working on the adoption of something that is paradigmatically different and has an entirely different model when it comes to trust, privacy, availability, and network architectures and topologies. These can be interesting and long conversations. One of the groups of people who are, it's not awkward and is awesome to work with them is Brave. So they were the first browser to do the first browser with millions of users to do a full integration of IPFS, where they added support for the IPFS and IPNS schemes. You can actually load a full IPFS node from within Brave. When you go to an IPFS address, it prompts you to do some of these features. They bundled IPFS Companion super early. It's fantastic to work with them, but there are a lot of unsolved problems. So adding an IPFS node to something like a browser uncovered all these other things that you have to do when you're a browser and you need to communicate things to users, especially things about trust. So how do you visualize how connected your IPFS node is? Well, we learned earlier today that even if you try to estimate that, you're going to be wrong. You may be wrong for any given piece of content that you don't know how many people are providing it, or if they actually are, or if you can connect to them. Well, NAT punching will help maybe a little bit with that. What the system resource usage, things like how do you communicate? Like with SSL in the browser, you use the lock. And that gives you more information, and you can get more information from the certificate about whether you should trust the entity that you're loading a web page from. But when you are loading a CID, what does trust mean? Where do you get that trust? Is it out of band? There's no certificate really that you can get single business entity information from or anything like that. Where's your stuff? You can load a bunch of stuff in Brave over IPFS, but how do you get to the node? There's not really a way to visualize it. So a lot of new things that we still have to figure out when thinking about what IPFS means in the hands of regular people at scale. Chromium, to visualize to scale here. We're working with a company called Ayala, and they've been doing web consulting for over 20 years. They have commit privileges to Gecko, WebKit, and Chromium. And we work with them to be able to fixing like browser compatibility issues. So when you have a IPFS web app that you want to load from a local node, we needed to make sure that the local host handling from a security perspective and a capability perspective in browsers was consistent. So we were working with Ayala to fix some of the issues around there and actually make kind of like, not just for IPFS, but make local host node development patterns for decentralized projects easier for everybody. And now we're working with them to refactor Chromium to basically add better support for non-HTTP protocols. So Chromium, if you ever looked through the source code, it's a massive project. It's a universe of different companies, different use cases. There's lots of embedders of it, Chromium-based browsers, but also other things. And all of that code base is pretty HTTP blinders on. And all the way up and down the security stack, the permission stack, the network stack, which runs an entirely separate process. There's a whole lot there that needs to be done just to be able to add support for something that is not HTTP, let alone IPFS. So this is work that's been going on for at least over a year for just this refactor. Many conversations of patches, and basically every time they do a refactor and they actually get some significant pieces done, they uncover yet more of the Chromium code base that needs to be converted to be able to basically handle anything that's not HTTP. So this actually benefits not just IPFS and libp2p, but also any decentralized protocol or any non-HTTP protocol really that you want to add into Chromium. So this is pretty exciting that a lot of the core of that refactor has been done, and we're almost to the point now where we can add like basically a compile time flag to Chromium where you can specify the schemes that you want and be able to point them to a remote IPFS gateway, for example. So that's pretty exciting work, but there's still really a lot of stuff. And we want to be able to do things like native IPFS support inside things like Chromium to be able to have that support realistically usable by hundreds of millions of people. But again, many years of development, and some parts of IPFS itself have to change to be able to work in these environments. And we think of desktop class devices as being highly capable compared to phones or something like that. But when you're a browser vendor, actually adding something like a Go IPFS node is kind of untenable out of the gate for a lot of different reasons, from security standpoint to just knowing what the software is doing. Brave is doing some amazing things in experimenting with that, and we're learning a lot. But looking at the long term, architecture of native IPFS in browsers, we have to kind of reevaluate that node-oriented model. We're doing a lot of stuff with browser extensions, which has become problematic. One of the big challenges that we have right now is we had to rewrite IPFS Companion for what's called Manifest v3. Google has decided to re-architect how browser extensions work for somewhat good reasons, performance-related, security-related, user safety-related, but it also radically reduced the surface area of features that you have as an extension developer, which meant that we can no longer do a lot of the things that we did in IPFS Companion before, and we have to rethink what the IPFS extension will actually do. We kind of thought initially that it would be on a road to eventually implementing IPFS in browsers, but that door's pretty much shut with Manifest v3, and it's not really going to be possible. So we're trying to think what we need to do there. We already have our rewrite of IPFS Companion done, but there's a lot of other stuff that needs to happen there, and actually Google's running pretty behind on this shift anyway. Mobile is another area where IPFS doesn't really fit well with the network architecture of these devices. Birdie, who is our awesome hosts here, who we've been working with for a couple of years, are doing amazing things. So they did the BLE, the P2P transport, which is really going to offer us the ability to do things through IPFS on mobile devices that we couldn't before. But at the same time, and they also embedded Go IPFS into mobile and added native bindings for Swift and for Android as well, which made it easier for other applications to be able to use that. However, we kind of have this like square peg round hole problem again, where you have a design of the implementation of IPFS which doesn't align well with the architecture of the devices that it's running on. And connectivity becomes really hard when that happens. So not only is it not natively integrated kind of into the OS SDKs, but also has a device kind of weight, both in CPU, battery, bandwidth, that doesn't align well with common mobile use cases. So if you're on Wi-Fi and your phone is plugged in, you can go all day doing something like embedded Go IPFS on your device. But if you're going to work and going in public transportation and moving around, having a bunch of persistent connections running on the application in your phone isn't really tenable, and that's not going to work. So again, we're in the situation where we've got things working in some interesting ways, and they've done really unbelievable things. But for the long term, we need to really reevaluate kind of what IPFS is and how it works in order to be able to get to work in a way that aligns with the model that these device architectures are designed for, and the type of connectivity that they have available. Durin is a new project that we started this year for native iOS and Android applications that are basic use cases. So it's going to enable basic sharing, like how can I just share an image to IPFS, or can I download an image or an image that's already on my device and add it to my IPFS somewhere. More of an experimentation platform at this point. We're going to add some features like being able to send all your photos up to NFT.storage or Web3.storage, things like that, save them to Filecoin, integrate with remote pinning services, be able to see the list of images that you've shared or that you've saved and things like that. But again, there's not really a kind of like way that IPFS fits neatly into how you think about mobile use cases at the operating system level. So when you save to IPFS, which IPFS does it save to, again, kind of like where is my stuff problem at the application layer of working with IPFS. But also when you want to publish to IPFS, if you don't have, say, an account with some service that's going to host and persist your stuff, where are you sharing to? So there are these flows that we need for regular users to be able to like save and load from IPFS all day, every day with the things that we all do that have to be figured out at the operating system level. Things like where do your photos go? So do you keep a full copy of the photos when you add it to IPFS locally? Do you save it to your photo roll in the operating system? Should we have integration of things like a local IPFS data store that exposes itself the way that some applications do into the local photo roll? Lots of stuff like that to figure out the application layer that would make it easier to work with IPFS. Agrigor is an application, it's a browser that was designed to be multi-protocol from the beginning. So it had DAT bindings, it had IPFS support and things like that. We just started a new grant with them. They're working with some folks, basically some mesh networking folks in South Africa, to design a mobile version of Agrigor that's a rebuild of Chromium, but with IPFS added, and with kind of an application model built on this mesh networking capability that's going to be super interesting. They have gotten pretty far, actually. And in this challenges section, I was going to talk about what they did, but they just published a blog post yesterday or the day before that's all of the challenges that they've had so far in trying to actually kind of recompile Chromium, but for Android, but with alternative protocol like IPFS in there. It's a super interesting read and really gives you a view into how difficult it is from an engineering standpoint to take these things that were really built for IPFS or for HTTP only and add things like IPFS to them, especially in really constrained environments like mobile, and especially when the source code base, like things like Chromium, are fairly complex. So a lot of it is wrestling with build systems and things like that. Capulun is a mobile operating system, which I have one of these phones with me if you want to check it out. I've flashed it to a Pixel 3 so we can try it. But this is basically the KaiOS operating system, which was based on the Firefox OS operating system that you may remember from 5-10 years ago. I was a project lead on Firefox OS and got it shipped on a whole bunch of phones. So I'm pretty familiar with kind of the core architecture and how to do this. And some of these folks from KaiOS wanted to do some experiments with Web3 technologies. So we gave them a grant to be able to add IPFS and Filecoin support to Capulun. So today you can take an image that's a GSI for Android phone. So it runs on basically any device that supports, I think it's Android 9 or above. You can flash Capulun to it and get a basically functional, minimally functional web-based operating system that runs web apps as apps, has support for IPFS and IPNS protocols out of the box, has MetaMask bundled with it, and we're going to be able to use that as an experimentation platform for what a native Web3 operating system might look like that's also web-native operating system, so not based on iOS or Android. Really interesting from an experimentation factor. There's lots of projects that we're going to talk to that they want to try this out as the base for their mobile operating system, or for at least reimagining kind of what a mobile operating system world could look like when it's kind of with our values defined for the people that are at an event like this. So that's pretty exciting, and those images are available right now at capulun.org. Even the images are being distributed on IPFS, but some of the challenges are using a kind of daily driver IPFS-based operating system, found out all kinds of bugs already in our gateway implementation, in some of the persistent services that we've implemented. So it's been great to be able to get that feedback. And once you start doing experiments like this, kind of going all the way with IPFS, you start finding issues that affect everybody. And we've found and fixed already a couple. So the value of that has been pretty great so far. Some of the other places we're putting IPFS where it doesn't quite fit neatly are different open source tools that you might be familiar with. So Mark Geiser, who's here, has been working on, and actually just recently it got landed. Ooh, congratulations, Mark. Support for IPFS in FFmpeg. So this means that IPFS can be available inside media tools, all different types of TV and entertainment stacks. FFmpeg is used in so many different places, so the ability to have IPFS be a default available loaded data source for FFmpeg is really important. It started out as a grant, and after a very long typical open source negotiation with FFmpeg and the community there, actually got it landed, and we'll ship in the next version, which is super, very cool. Some of the challenges that we found were how do you configure IPFS gateway defaults without just always going to IPFS.io? How do we detect local node support in things like CLI applications and fall back to those? And then also, how do you communicate when that fails? So we ended up doing development of a bunch of strings that developers can use kind of as the base of how to communicate when things are working or not working in the integration of IPFS and tools like this. Another one is curl. So that's probably a tool that a lot of you have heard of. Here are some of the challenges that we have. Badger was super interested in doing this, but kind of his first questions were well, I can't find the specs. What even is IPFS? And again, there is no kind of idiomatic IPFS. It's a toolkit for building things like this. And so it's been an interesting conversation around what does IPFS integration into something like curl look like? When it's not supported in the operating system, you have to do a lot of work at the tool level and at the library level to kind of define what that behavior is going to be, and it's not going to work out of the box for everybody and for every use case. So it's been really interesting to walk through the implementation of these tools, and there's still a lot of work yet to go on this one in particular. Another area where we're trying to get things like IPFS in, and it's not really easy, is into operating system file explorer. So things like Windows Explorer or Finder and whatever your Linux distribution file explorer is. The same guy who's working on FFmpeg and WebDev and the curl support, Mark, is here today, and he's also working on this WebDev integration. we tried to get IPFS working over Fuse for a long time, which is still ongoing and yet to be completed. So one of the ways we thought about doing is with WebDAV, which makes it a lot easier because IPFS already has pretty strong HTTP support. We could add some WebDAV extensions, do some development there, and see what we can actually make happen. And as you can see here, Mark did get a hacky prototype of this working, so we're investigating what the road forward is, kind of to be able to get that working better and more usable. IoT is another one. IPFS Tiny is an implementation of a subset of pieces of IPFS in C++ designed for embedded software and microcontrollers. They have some of the basic pieces working. I think IPLD just got finished. There's some IPFS C++ out there, but it wasn't really fully completed and not totally usable. So hopefully this will be a more usable implementation with a open source community behind it. The folks from LibreSpace, who I'll talk about in a second, are doing a lot of this work, but it's been interesting and difficult because, again, like the network architecture of a lot of these devices means, and the constraints and type of transports you have available mean you can't get a full P2P stack. So you kind of have to reimagine how does the communication topology of IPFS work when you might have a bunch of sensors that are emitting data that may be phoned home to a centralized gateway that then provides that data to the broader IPFS network. Or you have things like broadcasted sensor data. And you have somebody just harvesting all this broadcast data and making that content address data available to the network. So we've been doing a lot of experimentation there, trying to figure out how that's going to work. Space, IPFS in space. So the people that did that previous implementation also launched satellites. They're an open source space group from Greece, and they're working on adding IPFS into one of their satellite launches. Hopefully that's going to happen either end of this year or the beginning of next year. There's been a long-running grant that we've had with them. We're also doing work with a couple of other different entities that I cannot name yet, but hopefully by next month we'll be able to talk about it, around space-to-space communication, space-to-ground station communication, and also more interesting things like lunar communications. Some of the bigger telcos now are even talking about how to do things like 5G on the moon, which sounds crazy, but is real. You can go to areweinterplanetary.org and keep an eye on whether or not IPFS is in space yet. I think I had a whole section. I mean, this could be a much, much longer talk, and I kind of did the speed run through it. Happy to answer any questions that people have about these projects and talk with you about it. I'll be here all day tomorrow as well. And there's like a whole area of metaverse that is kind of ill-defined. It's not really clear how IPFS and NFTs and all these other P2P technologies fit into it. We're working with a lot of these projects, and we have ideas why we think things like content address data would be very, very important in an open standards and interoperable approach towards metaverse or even just basic like WebXR use cases and implementations and integrations. We're talking with some of the browsers that have implemented WebXR to be able to have, and some of the toolkits too, things like A-Frame, to be able to add better support for content address data and IPFS data into the development experience for that kind of stuff, but it's not quite there yet. So I think there's maybe next year I'll come back and talk about the stuff that hopefully we have done in there since then. But that's it. Thank you for joining for this very, very quick tour of all of the places where we're trying to put IPFS in strange spaces. And I can answer any questions. Or point you to somebody who can.
Yeah, we have. Hi, thanks for the talk. You briefly touched on this, but what is the general feeling about whether support for IPFS needs to be at the operating system level, right? Applications don't have to do their own DNS lookups. They just hand that to the operating system. And because also if you have multiple applications on a machine doing IPFS, you don't want each of them to have to be running a node. So is that like too ambitious that it would be in the operating system, or is that focusing on that?
I don't know about focus. As you saw here, we're kind of spread across many different areas. I think it has to be an inevitability for IPFS to function performantly at the operating system level for a broad swath of applications. So like you said, like it's a pretty basic challenge. If IPFS adoption starts to grow, you get one IPFS node on your computer. And then you get two IPFS nodes on your computer. And that problem, it can grow really fast, especially if each one of those nodes is one, like taking up disk space, using CPU, but then also opening up hundreds of TCP sockets too. So that's a serious problem that we have to figure out with adoption. There's been a little work, like some of the work around making sure that IPFS nodes in web browsers with JS IPFS can be shared across tabs. Kind of started poking at that problem in the web content layer, but even at a lower level, like at that point, you have the browser kind of proxying and managing network connectivity for you, and browsers do a lot more than I think people give them credit for in doing that, kind of protecting your system from bad web content, and not bad by malicious, but like poorly engineered web content. And I think that has to happen. It's inevitable. That has to happen at the operating system level for this to really, really grow and scale, where like you have many, many hundreds of applications running on your system that are all using IPFS. And network is just one problem, and system resource usage, but also like data sharding. Like right now, your IPFS repo is just one giant kind of global space of data, and that's not really functional for a lot of different types of applications. So I do think operating system support natively eventually has to happen at some level. And I think probably that will engender changes in the architecture of IPFS itself, how we think about IPFS, especially, and it's probably related for folks here, at the network layer.
Thank you.
Any other questions?
Other question, guys?
Hi. So you mentioned that the Libre.space are using the C++ implementation of libpeer-to-peer. I understand that it was like 4 years ago when Rust kind of wasn't a big thing, but currently the embedded Rust space is pretty big now, and I would say it's like somewhat safe to rely on it. So do you know some of their thoughts or potentially for getting Rust libre-to-peer into this?
Oh, yes. This was a conversation before a line of code was even written. And we definitely went kind of round the round. Like, there's a lot of folks who were like, yes, why not do Rust from the beginning? And the folks that are working on, so Libre.space are actually writing that implementation in C++. And one of the reasons why they're doing that is because while the embedded Rust space is growing, the embedded space as a whole is very, very slow to change and very resistant, especially to changing at that scale. And so the advice was, all right, or the kind of the decision there was, we're going to need both for probably 5 to 10 years. And while Rust embedded space continues to grow and mature, new devices are coming online that are friendly to Rust and really happy to be able to have that choice, can take advantage of Rust IPFS implementations and Rust libp2p implementations as they mature. But for a lot of devices, if we want IPFS capabilities to be available today for those devices, we need to have a C++ implementation that they can choose. So it really was a pragmatic decision around, well, okay, how many devices out there are running Rust versus C++? Well, come on, like they're all running C++. Almost every internet-connected device is going to be embedded anyway as C++ at this point. So that was a very practical decision that we hope will at least get us a few years, if not more, of usage, and probably a long tail, much longer than that. Whereas as Rust usage grows, we can encourage new users and devices who are open to making that decision to do so.
Thank you.
Yeah.
Great. Any other takers? Well, thanks a lot, Dietrich.
Cheers. Thanks.